So I'm just gonna spend a little bit of time, maybe not doing every single question, but I was thinking question 3 or 4. Would that be a good one to start? I don't know if you had a tough time with those. Basically, question 3. If you just make sure you keep things, you clearly state what you're starting with. What are you given? Then you know where you're supposed to go, right? So it says that the floor plan for an apartment shows a rectangular master bedroom is 5 centimeters by 4.5 centimeters, and I will emphasize that it's not the actual room, it's a floor plan, right? And that's a diagram if you ask me, right? So diagram is given, right? Diagram given. It's better to use diagram and actual in this scenario. And so I'm given that the length is 5 centimeters, and that the width is 4.5 centimeters. Okay, so when you compare the two objects, in this case it's a room, right? There's a right in this case there's actual in the diagram, and something happens. There's to go from actual to diagram or diagram to the actual. A scale factor or a scale has been used to make that change. Every single dimension has been affected by the same amount. Okay, in this case, they tell us that the scale factor, if it's a scale factor, we're talking K, and it's 0.02, no units, right? The units kind of canceled out to get there. And so you just have to do a little bit of calculations for that. So we know that K will be, it could be the radius of the diagram, the length of the diagram, the width of the diagram, but it's nonetheless dimension of the diagram over actual. Always keep this in mind, okay? And so I will set it up, right? Saying that for the length, if I do my work here, I'm given that K is equal to the length of the diagram, which is 5 centimeters, and you don't know what the length of the actual room is. So you make that your unknown. So we're going to use, this is a proportion, correct? And this is the trick I always like to tell my students. If you take any number and you put a 1 underneath it, you're not changing the value, right? Like 1,000 over 1 is still 1,000, right? And then you can see clearly that you have to cross multiply that way and divide going up. So it'd be 5 times 1 divided by 0.02. Oh, I didn't clarify this. Why did I assume this is centimeters? Because that's what I'm given. Because remember, a scale factor, to get to it, you need to be able to cancel the units, right? So if I start with miles, then I'm assuming that the other number will be miles as well. Yards, inches, you get it, right? So this gives you, is this 250? Yeah, 250. And what are we in? We're in centimeters. They want it in meters, no big deal. 1 meter has 100 centimeters. Cancel, cancel. That's 2.5 meters for the length of the actual room. You repeat this step, so I kind of break this and say that now I'm going to do the same work for my width. So 0.02. The width is 4.5 centimeters. So this is going to be y centimeters. You put the 1 underneath. You know you have to cross multiply and divide. So 4.5 times 1 divided by 0.02. Y is equal to 225 centimeters. You multiply that by 1 meter as 100 centimeters, or you just shift the decimal. I'm fine with that. Oops, it's supposed to be meters. Yeah, sorry. And a lot of you were commenting on the AC. You weren't sure. I did it a different way. Is it okay? Absolutely. As long as you're consistent, right? You'll be fine. So now basically what you've done is you found that the actual length is 2.5 meters and that the actual width is 2.25 meters, right? And that was related by a factor of 0.02, sorry, right? So now you know both of them in that way. Does that make sense? Don't you like the over one thing? It makes it easier, right? It's like, oh, okay, I see the proportion there now, right? So make sure you understand that. Then I'm going to do question 4 real quick. I always say real quick and I end up taking longer because I want you to understand it. So question 4, a computer chip on a circuit board has a rectangular shape and it's 6 millimeters by 9 millimeters. Is that the actual or is that a diagram? Actual, right? Because it's the actual computer chip. So actual given, and I know that my width is 6 millimeters and length is 9 millimeters. Okay, there we go. So you want the diagram there on the other side because, right, that's what's going to happen. And you know that these two are related by a scale factor of k is equal to 15. Okay, it says it right there. Okay, and you want to draw it. So let's get back to the drawing board here. So we know that 15 is diagram, which I don't know, and it's going to be in millimeters as well. I know that the actual computer chip measures 6, right? So I put the 1 here. So I have to cross multiply up, divide by 1. 6 times 15 divided by 1, that's 90. Right? And I'll do the length right next to it. 15, same scale factor. And I'm going to call that y. And that's 9 millimeters. Okay. You put the 1 underneath. You can do the 1 trick on a decimal. You can do it on a whole number. It doesn't matter. It's the same thing. Some of you are still you're not believing what I'm saying. So divide it by 1. It's still the same number. Okay. If you don't believe me now, go Google it or something. And divide it by 1. 120. You should be able to draw something like that. 90, yeah, it works. Maybe not on this paper. I don't have enough room here, but you should be able to get 90 millimeters by 120, right? And then we label it with the actual dimensions. Okay, so you'd have to label it 9 millimeters by 6 millimeters, right? But you're using these numbers to draw it. Okay, so it's this would have been done the exact same way if they had given you a scale, because watch this, this is pretty cool. When they say a scale factor of this, then it's really 15 over 1, right? How would you, like, remember I told you that you can go from a scale to a scale factor and that this number is always on the left and the other number is on the right, right? The bottom is so if they had given you this, you would have transformed it into a scale factor and then done this the same way. Okay. I always prefer it as a scale factor, but you don't have to. You can just keep it like this if you want, and then use that for your proportion. And the funnest one of all, and I realize this may be part of your notes. I forgot to give you the fuel economy formula. So if you have this booklet, maybe write it next to it. I will tell you I will give you the formula right next to B. Okay? Fuel economy is liters over distance times 100. I just thought I'd give you, you can do it without the formula, but I just thought liters used over distance times 100, and your answer is going to be, right, liters per 100 kilometers. Okay? When you use that formula, you get liters per 100 kilometers. And I realize that this question is like the answer is 1.75 and it's way too low. Like no car, not even a hybrid, can do 1.75 liters per 100 kilometers. But don't focus on that, just focus on the steps required. Okay. Question 5, and then we're done. Then I'm moving on with the notes there. Let me just make sure I can see everything. I'll block the first two. So it says Connie drove from Winnipeg to Lethbridge and drove 740 miles and took this long to drive, right? 13 hours, 51 minutes, only stopping once for gas. Took 10 minutes, I guess, and 55 minutes for dinner. She used 5.51 gallons of gas, and the fuel cost $14.54. A lot of information, but just take it one step at a time. A, determine the average speed in kilometers per hour. If you took physics or science, right? Speed is distance over time. And if you didn't know that, it does ask you to state it in kilometers per hour. So as long as you do that, you're fine. Okay, so let's talk about distance first. We traveled 740 miles. We want that in kilometers. 1 mile has 1.6093 kilometers. I think I got that right. And if you're, I don't know if you've been using this one for homework. I should have told you. If you ever press a button, you're like, how do I get out of it? If you press second and then the button right beside it, which says quit, it gets you back to the home screen. I should have told you that, but you try it, right? So 740 times 1.6093, that's 1190.882 kilometers. I'm going to leave it like that. I don't want to round just yet. And then time, how can we do this so it makes sense? It's 13 hours and 51 minutes. That is equal to 13 times 60. I'm just going to do it like that, plus 51, right? Let's get it all to minutes. That's 831 minutes. But we didn't drive the whole time, so we have to subtract the time that was spent gassing up and the time spent on dinner. So I'm going to go minus 65. That's 766 minutes. Why did I do that? You could have converted these, right, the 65 to hours it's up to you, but I find it easier getting everything into minutes, then coming back and saying 766 minutes. I will convert that to hours, right? 1 hour has 60 minutes. And that's 12.7667. 12.7667. I'm going to use 4 decimals because I'm not done yet. And that is hours. And now is my, so this one here and this one here are the two that are going to get me my speed. 1190.882 kilometers over 12.7667 of an hour. This is a rate, remember? We're going to get it to a unit rate. So really all you do is 1190.882 divided by 12.7667. Did I get that right? I think so. 93.28 kilometers per hour. What do we call this? A unit rate. Okay. And this is a rate, but they're the same. Okay. So that's my speed. That answered A. I need to answer B. And so fuel economy, let's just use that formula. This liters that I've used, problem again, right? So I'm going to go 5.51 gallons. I'm going to turn that into liters. 1 gallon has 3.79 liters. And that's 20.8829 liters. Because you want it in liters per 100 kilometers. So important, right? So I'm going to go use that formula over, where's my distance? 1 second. I need to go check my paper. 1190.882. 1190.882. And let's just make sure this is liters, kilometers. We multiply that by 100. So you go divide them, then multiply your answer by 100. 1.75. We round it to 2 at the end. But you got to make sure this is that many liters per 100 kilometers, not just per kilometer. I have to change that question. Something is very wrong with that. I was going to say not even an electric car can do that, but then again, electric cars don't use any fuel. So, what's the average cost per liter of gas? This is how I would do it. This is how I would do it. If I paid $14.54 for 20.8829 liters, you see where I'm going with this, right? Then, how much would it cost in dollars for just 1 liter? I'm going to get a unit rate, which you could have also just divided this, right, to get it. So times divide. So X is 1 times 1 liter times 14.54 divided by 20.8829 liters. The liters go. And and it's 14.54 divided by 2882. That's 0. Does it say how many decimals? It doesn't. So we're going to round it to 2 decimals, right? 0.70 cents per liter. Go. Does that make sense? Some of you are like, yeah, I did the homework. Why wouldn't it make sense, right? And some of you needed the review. So there you go. There you have it, right? Courtesy. Okay, so that's that. So keep this booklet, but we're going to put it aside for now and continue with notes. So last period of the day, your bellies are probably saying, I need to eat something. I need to nap. Scale factors continued. Scale factor continued. So you will notice that I tend to go scale factor. Instead of scale, I will try to go scale factor if I can, but not always is it necessary, okay? So here we go. For example, convert the following scales to a scale factor. So let's say you're given, let's start easy. Let's say you're given that. And let's go B here. Scale factors cannot have units, all right? Scales can, but scale factors cannot. So let's go ahead and do that. You take the first number, take the second number with the unit. So that right there would not quite do it yet. So somewhere on this piece of paper, if you were to answer this question, we would want to, I at least would say, let's convert the meters to centimeters. 1 meter has 100 centimeters. Cancel, cancel. That's 2,300 centimeters. Okay, so I will then just proceed to saying that 1 centimeter, I've converted that, has 2,300 centimeters. Now we get to do this. Okay. So it's just 1 over 2,300, and we can leave it like that. No units, right? And this next one, I might just do it right underneath it here. I'm going to convert the 1 foot to centimeters. I know that 1 foot, it does matter, right? Foot is in the numerator, sorry, right? To start off, so I need to make sure I have a foot in the denominator. And what is the ratio here? You got to help me out. 3048, right? I'm going off script. That's why I'm asking you. Half of these questions I don't have a key for. Okay. Feet cancel. I want it to centimeters. So since the meters are up here, I'm going to make sure the 1 meter is there. 100 centimeters go there. Cancel, cancel. So right now it's just 1 times this times that, which is 30.48 centimeters. What have I just done? I've converted the foot to centimeters because I know that when I'm coming up with my scale factor, I'm going to have that. Does that make sense? It's too quiet. I'm not sure if you're convinced. But anyways, you have to believe me, right? You don't have a choice. Centimeters, centimeters, gone. Now, in this case, this isn't really pretty, right? A decimal denominator, I'm pretty sure you would lose marks in IPR if you left it like that, right? So what can we do to get rid of that? How many decimals? 2. So if you multiply both by the same number, you're not altering the fraction. So this would be 100 over 3048. I'll give you some good news though. You won't have to reduce fractions. Isn't that good news? And we don't, because I'm telling you why. Not that it's a good skill. Don't get me wrong, but we're gonna have so many fractions that if you get them wrong and then we later graph our lines, it's just gonna mess everything up, right? So I'd rather just keep it that way. We can use our calculator and then go from there. I'm not sure if these ones do it, but let me just try it one time here. If you were to go 100 divided by 3048 and then go math and just select that first option, it technically turns your decimal into a reduced fraction, and there it is. 25 over 762. Isn't that cool? Math and then 1, right, gets you 25 over 762. But this is what I do want you to be able to write. K is equal to 25 over 762, or you just go 100 divided by 3048, 0.03, right? You should be able to state it as a decimal, or you take what's on your screen, multiply it by 100, and write down 3.28%. Not 3%, 3.28. You go by what's on the screen. So scale factor can be stated in all 3 formats. Okay. Okay. Reduction or enlargement, right? So sometimes I will ask you, what happened here? Is there a reduction or an enlargement? So if the value of k is greater than 1, right? K is greater than 1, right? the original slash actual has been enlarged. So if this is your original, then right, let's say it's 1.75, right? K is 1.75, then you will have an enlarged. So this could be a new or diagram, same thing. K is equal to 1, no change. You essentially have the same, you have a copy of the original, right? If K is equal to 1, you're just making a copy. If K is less than 1, the original or actual has been reduced. So if you're having a blueprint of a big room, the scale factor will be less than 1, right? Because that's the actual and you made a smaller version of it. If you're looking at a microscope, right, the cell is the small one, the actual, but the image you're looking at is greater, so an enlargement has been made. Okay. So tell me, we'll do word problems here. I'm just contemplating here. Are you going to run into this? So example, K is equal to 3/4. K is equal to 380%. K is equal to 0.95. So in each one of these, could you tell me what happened to the original? What happened to the original in this case? It's a reduction, right? Because K is less than 1. K is less than 1 reduction. Of the original, that is. Okay, block that off. 380% enlargement. Let's say you're not sure. How do you turn a percentage to just a number? Divided by 100, right? So it's 3.8. So 3.8 is bigger than 1, right? So K is greater than 1 enlargement. Block that off. Here, this is very obvious. K is less than 1 reduction. So that's just, I can throw fractions at you, whatever. If it's a fraction, divide it, get your decimal, right? So that you have it, so it's easier to see. Okay, let's do some word problems here. This is my paper going around that spreadsheet. Yeah, has everybody signed or initialed it? Okay, I'll get it in a bit. Word problems. The diameter of a cell is 0.25 millimeters. In a textbook, the same cell is depicted with a diameter of 3.5 centimeters. A. Determine the scale used. B. State the scale factor. And 3 forms. C. Is this an enlargement or reduction? By how much? I'm going to wait a little bit so everybody can write it down. All right, so here we go. The scale used. Right. So remember, if you're talking scale, we, in this case, textbook, picture, I'm going to use diagram, and actual. Okay. And I'm going to get it to 0. I'm going to do it right under here. So the textbook is the diagram. So 3.5 centimeters. And the actual is 0.25 millimeters. Now, technically, a scale can have different units, but we don't like decimals. That's the thing. We don't like decimals. So you treat it like a fraction. So look at both numbers. Which one has more decimals? This one has, right? So there are 2. So you multiply this by 100. You multiply this by 100. And you get 25 millimeters. And here you get 350. You have to keep the units in because they're different units. Okay. It's okay to have different units. Okay. No decimals. So it's okay to have different units, but it's not okay to have decimals, okay? That solves the problem. So the side that has the most decimals is the one that you're gonna multiply both sides by. So if this one had 3 decimals here, you would multiply it by 1,000 and by 1,000, and then you get it to a non-decimal state, okay? If that's even a word. Okay, B. State the scale factor in 3 forms. Scale factor, diagram, over actual. That's how we want it to look. Let me just move it up a bit. right? This is what we want it to look. So we just replace, right? So K is equal to, I can actually just go up here to the previous work. I'm going to start from scratch. Watch this. I'm going to go 3.5 centimeters over 0.25 millimeters. Okay. Convert. Okay, convert. Which one should you convert? And my answer would be convert the biggest unit to the smallest. That's what I would do. Okay. So convert centimeters to millimeters. So let's keep going here. This is just times 100. I allow you to do that. Sorry, not that by 100. Sorry. 1 centimeter has 10 millimeters, right? So you're just going to multiply that by 10. Just the top, right? Not cool. What are we going to do to get away from the 2 decimals? Times 100 times 100. So that's 3,500 over 25. And this is what I want you to do in this case. Always try out, see if it is a whole number that you get in fact, right? So 3,500 divided by 25, it's exactly 140. It's exactly 140. So this actually ends up being 140. You can say over 1 if you want, but it is really just 140. So the scale factor is 140. No units. Okay, that's my final answer. Wait a minute, what about decimal? What about percent, Mr. Dirksen? Yeah, decimal you can't do, but percentage, just go 140 times 100, right? So that is, sorry, that is, right, times 100, that is 14,000%. See? Enlargement or reduction. Since K is greater than 1, the actual or the original, it's either one, like whichever one you choose, has been enlarged by a factor of 140. So whatever your scale factor is, that's what you write down. So your scale factor, let's say this had not been as a situation where it's a whole number. Let's say this would have been 138.79 if you get it as a decimal. Then you could say that by a factor of 100, right? Like whatever you get when you divide these two, that is what you can mention here. Okay, so I would say get rid of the fraction and then just look at the number as a decimal perhaps, and then make your final statement. Okay. So you're still copying, so I'll wait a bit. That was the worst part about online teaching. I never knew when students were done copying and they were, or maybe they were too busy checking Facebook. We were watching you. Anyways, You weren't doing that. You were paying attention. Okay. Question 2. The actual length of a pool is 20 feet. And its width is 15 feet. A scale model of the pool has a length of 30 inches. A. State the scale. How about we reduce this one? B. State the scale factor. C. How much larger or smaller is the model? You have to think on those ones. Think about, and I hope you're updating your study sheets on a regular basis. If the pool floor needs to be painted and 1 can of paint covers 115 square feet. Comma, calculate. This is a run-on sentence, isn't it? Calculate, I would not do so well in English. Calculate the total cost if 1 can is 75 bucks. You have a little bit of time. So why don't you try A and B? You can do it on the side. Please. Okay, so scale. We want diagram, actual. I'm using diagram actual because the scale model, right? It's a diagram. It's a smaller version of it. And so you have to be careful here. Can I be more specific? I'm going to say it has to be, in this case, length of diagram and length of actual. Like it's got to go length with length, width to width, radius to radius, diameter to diameter, you name it. Okay. So in this case, I have the length of the model and I have the length of the pool, the actual pool, right? So it's those two that I need to compare. okay? Even though they give you the width of the actual pool, it doesn't really help you all that much in this case. So we got to go length of diagram is 30 inches and length of actual is 20 feet. Does that make sense? You got to go length with length, okay? There can be a little bit of reduction. I don't know how your teachers did this, divide both by 10 or cancel trailing zeros, right? So this can actually be written as 3 inches, 2 feet. We're going to leave it at that. And for B, scale factor, again, length of diagram, length of actual. I'm specifically referring to the lengths. I know that the formula just says diagram actual, but it actually needs to be the same corresponding side. You can't just say, oh, I'm going to take the width here and compare it to the length of the other one. It doesn't work that way. Okay, so length of diagram is 30 inches. Actual is 20 feet. There's some conversion that needs to happen here. 1 foot, 12 inches. And that's 240 inches. I'm going to insert that there. Sorry, I'm going a little faster. It's not a race, Mr. Dirksen. 30 to 240, I would give you the mark right there. Check. 1 full mark. You can reduce it a little bit. I don't know if you cancel the trailing zeros, it's 3 over 24, which is 1 over 8. Let's try the calculator. Take your calculator. Go 30 divided by 240. Hit equals. I think you can just leave it like that, but I will hit equal. Okay. Then you go math. Press the math button. It's on the left side right here. There's a yellow, a green, and then there's math. And it's the first option. So you just hit enter. Then hit enter one more time. And watch that. A reduced fraction 1 over 8. It's just good to have. Might come in handy in grade 12. And but I'm going to leave it like that. For your test or quizzes, that's good. Okay. So that, and it's going to be 0.125, also 12.5%. So you need to be able to have all three formats there. Okay. And see how much larger or smaller is the model. So this is where it gets a little tricky. K is less than 1, correct? Just look at your number here. Therefore, 3 dots like that stands for therefore. The original or actual has been reduced by and this is where it gets tricky. It's actually by a factor of 8. Has been reduced. It's 8 times smaller. Does that make sense? Like, because if the actual is 8, then right. I'll figure something out. So let's just leave a blank there. I will find an easier way for you to figure that out because this involves you having to reduce a fraction, and I don't want that. Okay. Okay, we'll come back to it. D. D is asking us, we're almost there, folks. It's saying if the pool floor needs to be painted, right, one can covers 115 square feet. So what we need to figure out is the area of the floor, right? And so the area of the floor would be 20 feet times 15 feet. Which is 300 square feet. Right? That's how much we need to paint. So watch this. If one can covers, what did I tell you it covers? 115 square feet, then how many cans will I need for 300 square feet? You cross multiply and you divide. 300 square feet times one can divided by 115 square feet. Square feet goes. I get 2.608 dot dot dot. So I need approximately 3 cans for this, right? This implies whole units. All right. One more. I'm going to extend this a little bit because I looked at your homework and there's one question that throws some students off. So I'm going to make an E out of this. E. Determine the width of the scale model. We were given the length of the scale model, but we don't know what the width is. Okay. And I'm going to go like this. K is going to be the width of diagram over width of actual. So now we're being a bit more specific because they're giving us more information than what we need. So we need to make sure we line that up. So, oh, I'm going to just not have the equal sign there. Do we know what K is already? We've determined that already, right? K, once you find K, it stays the same. So you choose what you want to do here. You want to keep it as a fraction? You want to turn it into a decimal? It's your choice. I will go here and grab this fraction right here because I don't care if I reduce it or not. 30 over 240 is equal to, which one of these two is given to me? Only one of them will be because they're asking for the, right? So they're asking for the model, so they give me this. That's 15 feet. Should I keep it at feet or should I turn it into inches? What do you think? If you keep it in feet, then your answer will be in feet, so it's kind of weird, right? So 15 feet, 1 foot has 12 inches. 10 times 15 is 150. Add another 30, that's 180, correct? I hope so. So I'm going to change this. I'm going to keep this the width of the diagram, but I'm going to rewrite it one more time, just so you understand what's happening. because if I start with inches, then I'm gonna want the diagram, right? So it's cross multiply and divide. Why did it turn into a 20, folks? What happened? Mr. Dirks wants to go home. Phew. Anyways, nothing worse than making a mistake on live television. All right, 240. I don't make mistakes, really. Just testing you. There we go. So that's 22.5 inches. That is the width of the diagram, of the scale, sorry. Scale, obviously, but diagram, same thing. And here you go. Page, see this booklet, you'll be like, it's the same question, right? So I'm just going to go page 5 to 6 in the booklet. And the textbook has some good questions as well. And I will give you those questions. I selected only a few. 1, 4, 6, 8, 9. Okay. Some of them take no time. The booklet are a little bit longer. They're work. Some of them are word problems. I'll give you a little. Just read carefully, and you should be okay doing this. Now, I'm gonna stop it here. I will post the key to 5 and 6.